So, when I started as a physics major, I definitely glorified and romanticized it. I really thought that I would just start researching the origin of the universe in like a lab my first year, and I quickly began to realize that a physics major is very different from the glorified version of physics that I had growing up as a kid. So today I'm just gonna break down everything that was in my UChicago physics degree, and I specialized in astrophysics. It was a total of 19 courses out of the 44 total courses I took at the University of Chicago throughout my quarters over the 4 years. So yeah, let's get straight into it. I'm gonna break everything down quarter by quarter, every single class I took for this major. And it gets very interesting for junior and senior year because that's really where I took classes that genuinely helped me so much in my career. And I'm not in physics anymore, but it has helped me so much in the data science world, tech world, the business world. So yeah, I'll go through everything I loved, didn't love, and all of that jazz. And hey, for those of you who may not know me, I'm Priya. I went to the University of Chicago. I post about college, everything I've learned over the past few years. So don't forget to subscribe if you haven't already, and let's get straight into it. So I'm gonna tackle my first year all at once because these are essentially just like introductory core courses that every physics major has to take. I took all of Intro of Physics, which is 3 courses, Mechanics, Electricity and Magnetism, and Wave Optics and Heat. And then I took 3 math courses, Calc 1, Calc 2, and Math Methods in Physics. So let's hit all of them. Mechanics is really what you're gonna expect. It's stuff you learned in high school, like, velocity, acceleration, Newtonian mechanics, center of gravity, work and energy, conservation of energy. I'm sure you've heard of projectile motion, just all of these things that exist in the Newtonian world. So anything that's macroscopic and not quantum in terms of motion is what we learned growing up. So that's really what you hit, and you hit on all the theorems and proofs. It's a very standard course that you're gonna have at any university if you're majoring in physics. The second is electricity and magnetism, and I honestly hate this. Like, I have never enjoyed electricity and magnetism ever. It is too practical. The labs were like 4 hours long, and I had lab Friday night. It was just rough. And as someone who's in astrophysics, I am very theoretical, and this is the opposite of theory. It's very practical, so some of you may love it, some of you may not. But essentially, it's just all of electricity that you might have touched on in high school, and you go deeper and deeper into it. That's really what the introductory physics courses are. So this includes Coulomb's law, Gauss's law, anything about electric potential, circuits, magnetic field, and you actually get to work with electric circuits in the lab, Faraday's law, electromagnetic waves. So you really hit on all of the basics of electricity, electrodynamics, and a bit of the electromagnetic spectrum, which is very cool introductory stuff, though, I will say, to astrophysics, because I took a radiation processes and astrophysics class that honestly, like, this was a great primer for that. So I'm not gonna hate on this class that much. It was good. The third one is Physics 133, which is the 3rd course in Intro Physics, 3rd and last course, Waves, Optics, and Heat. So here you really learn about wave motion, sound, light, inference and diffraction, and you actually do end up hitting very slightly on quantum mechanics. You hit on wave-particle duality, where matter in certain cases, depending on microscopic or macroscopic level, functions as a particle or a wave. So that's really one of the biggest parts of quantum mechanics. You hit on that a little bit, which is awesome, but it's really about like mirrors, lenses, optics, polarization, and all of those double slit experiments. It's cool, and lab is very interesting. I wouldn't say intro physics is really my favorite at all. I honestly am not an intro physics person. I feel like I'm not good at the basics, but I'm good at the high level computational astrophysics stuff. So yeah, I'm probably not the right person to comment on it, but yeah, good intro course. Let's go to math in my first year. I'm not gonna say too much about this because Calc 1 and Calc 2, I took 151 and 152 if you are familiar with UChicago's system, which is right below honors calc, but is above regular calc. And this is really a prerequisite for most people who are gonna major in anything STEM related, especially if you're majoring in math or physics. And I'd say these 2 classes were very reminiscent of high school. Honestly, I feel like I could have placed out of it, but I didn't place out of it based on the test, so I took them anyways. And it was pretty much what I learned in high school. I took math higher level in the IB program. So if you took higher level AP calcs, you probably will do well in these courses. The first calc course, 151, was essentially like all of differentiation, integration, proofs, limits, the mean value theorem. And 152 was integration and a lot of limits regarding integration and complexities with that. So I'll go on to math methods in physics, which is an alternative to taking the third course of calc. You can take the physics one, which is actually heavily recommended. So most schools have something like that. This one is really just like partial differentiation, integral analysis, Fourier transforms, complex numbers, and really linear equations. So this is just all of the physics specific math that you're gonna need to apply in future classes. And physics is essentially just applied math. Like all of quantum mechanics is literally linear algebra. Like it's all linear algebra, it's the same thing. So if you take any of these math methods courses, it's just directly applicable to physics. So that course was great. So let's move on to year 2, which again, it was pretty much required courses that I had to take. So I'm gonna try to get through this fast so we can get to the good stuff junior and senior year. Modern physics, and I also took math methods 2. So that's a second class concurrent to the one we just talked about. So going into modern physics, I'm not gonna lie, I don't know why this is a real class because it's essentially just a baby quantum mechanics course. Like they don't go into the mechanics of the quantum world, but they start introducing quantum in a way where you're just like, oh yeah, if you go to the microscopic levels, Newtonian mechanics is wrong. So what Newtonian mechanics is just like a subset of quantum. So quantum's actually the umbrella and Newtonian mechanics is a part of it. And we're actually not taught that in school. We're taught that Newtonian mechanics is all of it because that's what we can physically see. So you start learning a bit about quantum, and in that you have to delve deeper into particles. So you learn about Bohr's theory of an atom and just like little chemistry adjacent things. But you also start going a bit into wave particle duality, Schrodinger's theorem, and you know, it's just quantum, but baby quantum, like more qualitative in baby quantum, which it's interesting, it's a fun class. And math methods 2 hits on a bit more of like the mathematical physics adjacent things like the vector space, more partial differential equations that are very specific to physics theorems that you will have to prove in further classes, and more series related things like Legendre polynomials and very specific things that honestly, this was 5 years ago, 4 years ago. I don't remember any of this, but that's what it was about. And yeah, it's just math for physics, you know? So let's move on to next quarter. I took intermediate mechanics this quarter, and I'm not gonna lie, this was absolutely the worst class I've ever taken. It was so mathematically inclined in things that I just did not understand or care about. And it was just like badly timed. Like college was rough. And this course, that quarter, I just was not having it. But you learn all about Euler's equation, the calculus of variation, Lagrangian and Hamiltonian functions. Those are the 2 main things you're gonna learn. And it's really all about work in Newtonian physics. So think of the mechanics course you took first quarter. This is like a crazy advanced version of mechanics. And moving on to quantum mechanics in my spring quarter of second year. I really loved quantum. I was not good at it, but I absolutely loved it. In quantum mechanics, you learn the uncertainty principle, wave particle duality, the spin, and when it comes to like, you know, quantum, you really just like have to relearn how you think about physics. So in the uncertainty principle, you learn that in those absolutely minuscule scales that you cannot correctly predict momentum and position in time. So it's really all about probability, and you learn that everything that happens has a probabilistic nature. So the fact that I walk one step in one direction in a macroscopic sense, you can see me walking. When I take one step, you don't know where my position in time is with complete accuracy. Like maybe my step was like 30 feet somehow. You know, it's really interesting stuff. And you learn about the fact that you can't really deterministically say that something is accurate or not. My battery just died, and in the last 2 minutes I forgot what I was talking about. But yeah, wave particle duality, Schrodinger's equation, the uncertainty principle, spin, and maybe the hydrogen atom. That's really what you're gonna learn in quantum. Moving on to math. In math, that quarter I took statistical models and methods. So that was just a stats class. Like it was a straight stats class in the math department, and we were required to take that to understand the basics of statistics in the physics world. So that's really like not a physics department course, and it isn't is physics specific, but yeah, just knowing stats and basic probability is really important in being able to assess, analyze, and synthesize large amounts of data when you work with data in physics, which is, physics is all data. So that's pretty much it for my second year, but I do want to caveat, I took a lot of history of science courses, which I absolutely loved. If anything, one thing I regret with college is that I didn't double major in history because I love the history of science. In this quarter, I actually took a history of science course about the German physicists in the 6 different eras of Germany, including World War II. So it was literally about physicists being extremely racist in Germany. It's so interesting the stuff you learn behind the scenes, especially when it comes to the atomic bomb. I actually took another course about the atomic bomb, so I'll go into that, but I would just really emphasize take courses that you also love outside of physics, and this is not physics at all, it's just history of physics, and I really, really love that. I also took several history courses like the history of extraterrestrial life, and amazing, amazing things. So let's go into junior, senior year where you hear about all the cool physics and all the cool history. My first quarter of junior year, I took 3 relevant courses. So the first was radiation processes in astrophysics. And like I said before when I was talking about the second introductory physics course, which is electricity and magnetism, here you learn about the electrodynamic spectrum in the world. You learn about neutron stars and massive electromagnetic differences in scale of those neutron stars. I wrote an entire paper about magnetars, which was super cool. You learn about Maxwell's equations, lasers, stars as black bodies, and you learn about all of the different emissions that you get from each stars using the electrodynamic spectrum. Super cool stuff. It is absolutely awesome. Loved it. And this is actually the year I start taking only astro courses because I finished my requirements for regular physics, and I loved every class I took from this quarter onwards. I also took computer science with application CS 121, which is the most useful class I've taken at the University of Chicago, hands down. Every physics major should learn Python, and that was our school's Python course. Literally, the professors wrote the textbook for that course. They taught it so impeccably well, and honestly, like, that's the reason I have a job. I became a data scientist. Like, I work as a data scientist now, and I credit it to that class because learning a language and learning intricacies, machine learning, all of that, and also the entire language in 10 weeks, I would think it's impossible, but I did it in that class. So that was probably the most useful class. That was required for astrophysics because you have to take a lot of computational astrophysics courses. Astrophysics is a lot of data analysis, and you need to know Python for that. And the third course I took was called the nuclear age, and I alluded to this before, but this is my entire class about the atom bomb. And actually, it's really cool, the history behind the atom bomb and its relation to the University of Chicago. So the Manhattan Project, which is really the project where they built the atomic bomb and research for it, actually is heavily correlated to the University of Chicago. And Enrico Fermi actually discovered the first self-sustaining nuclear chain reaction at UChicago. That actually happened on December 2nd, 1942, and December 2nd is my birthday, so it's really cool stuff. And that was actually the last piece they needed to build the atomic bomb, and that happened on campus. So yeah, we were part of it. I don't know if it's good, I don't know if it's bad. We actually met the last living person. He was 94 at the time when we met him. He came to class, and he was someone who was a part of the self-sustaining nuclear chain reaction research, and he was the last person alive, so it was super cool. It was one of the best classes I've ever taken, hands down. Next quarter, I took the physics of stars and current topics in astrophysics, so those 2 courses. Physics of stars, again, absolutely awesome, and again, I actually researched more about the magnetar, and my final paper in that class was about magnetars, but that class was all about the different stars and the Hertzsprung-Russell diagram, so it's really cool stuff. I really loved it. I have nothing else to say. And the second one was current topics in astrophysics, which is taught by a different professor each quarter. So it was about telescopes and all of the history and research behind lenses and moving from refractive lenses to reflective, and it was really interesting stuff. And I actually worked at a physics observatory after my first year on campus, so I already had a bit of a background in observational astrophysics, so super cool. Next quarter was cosmological physics, which is absolutely amazing. That was the coolest class I've ever taken, where you literally learn about the proof for the Big Bang. You learn about the cosmic microwave background, which is this radiation that still exists in our universe, which can't really exist unless something adjacent or like the Big Bang happened all of those billions of years ago. So it's super cool. You learn about all of these like stepping stones to actually find the origin of the universe. It's just very interesting. And our professor, literally was so smart. He got his PhD in like 4 years at Princeton, and he's been teaching, and he has probably one of the most cited papers in cosmological physics. So he's very good at what he does, and I learned a lot. We also had another astrophysics course, and that was similar to the observation techniques that I took the previous quarter. So I got really lucky where the current topics in astrophysics was like about observational techniques. Then I took observational techniques essentially again the next quarter. So the class was very similar to what I already took, and of course that leads to an A, which is nice. This is also the quarter I took history of extraterrestrial life. This was a history of science course, and it was so cool because it was actually taught by someone who studied astrophysics at Harvard, and she ended up, instead of being a scientist slash researcher, went the history of physics route and got her PhD in that. We learned about so much, and we learned that, you know, in the 1600s, there really wasn't a divide between religion and science, and that divide happened because Copernicus said that we weren't the center of the universe, or at least center of the solar system. And if we're not the center of the solar system, then in God's eyes, like, we are not that important. So that was the argument, and it was very, very interesting hearing the religious side of physics. And you read a lot of really cool sci-fi fiction books, and it was really cool that our required readings were sci-fi. Like, it was amazing. So loved my junior year. It was great. Moving on to senior year, I didn't really have a ridiculous amount of courses, and I also had my job secured. Like, the first 2 weeks of senior year, I kind of went absolutely insane, and then I accepted a job as a data scientist like literally 2 weeks in. So I was pretty much done and chilling. Well, I wasn't really chilling, it was very stressful still. But yeah, let's get straight into the courses. Fall quarter, I took statistical and thermal physics. So this is really all about thermodynamics, and it's not astrophysics specific. This was like more a physics requirement than an astrophysics requirement. So I kind of glazed past it. I can't really tell you what it was about, other than I learned about, you know, entropy and stuff. Yeah, all of the heat equations. This felt like a plug and play class. Like, I feel like I did all right. Like, this was a class like I ought to be in. Winter quarter, I took computational astrophysics, which is, yes, is so good. It was literally the class I have been waiting to take, and I learned everything. Like, literally all of these things I learned in computational astrophysics, you can use in all of data science, in all of quantitative finance. You learn about random walks, you learn about simulations for random walks, you learn about the Monte Carlo methods, all of Bayes. Like, you really learn like Bayesian inference, which is like literally like the most complex parts of data science and quantitative finance. That all stems from physics. Like, all of these things stem from physics. So it was absolutely amazing to learn all of that. It was a very hard class, but he was so nice. Like, he gave everyone A's, and like, I think the lowest he gave someone was probably a B, which is, you know, it's pretty cool because it was probably one of the toughest classes I've taken after CS 121. This was really all Python and all CS, but I loved it. I also took high energy astrophysics, which was a graduate level course for the master's slash PhD students. So I was the only undergrad in the class. I took it with a professor I took radiation processes in astrophysics with. He was teaching high energy, and radiation processes and high energy are essentially adjacent. Like, this is the more complicated version of that class. And at the end of it, we had like a massive presentation, and guess what I presented about? It was about stars. We also literally had equations that mapped out like black holes. Like, it was literally the mathematics behind black holes, which was very interesting and very hard. And my last quarter at UChicago, the 2 courses I took, the first one was research methods, I think. Let me check. Undergraduate research seminar. And here you learn about how to effectively present research techniques. And also we did a lot of reading abstract and complex research papers and trying to synthesize all the information down and work on the math that was on the papers. And the next course was science with large astronomical surveys. So this was kind of similar to computational astrophysics. Here it was all using machine learning to classify different stellar objects. So it was very like Python heavy, machine learning inclined. And this is where I really learned more about machine learning after computational astrophysics. And my end result was a model that could classify between stars and galaxies. All of these computational classes really helped me become a data scientist. I really liked it. And yeah, that's essentially my entire physics degree. And I hope this helped. I hope you're not deterred by physics. Thank you so much for watching. If you enjoyed the video, smash that like button and subscribe if you haven't already. That would mean a lot to me and the channel. I will see you guys at the next next video. If you have any questions or have any video requests regarding physics, I would absolutely love to make those videos, so comment them down below. And I'll see you guys at the next one.